Hey there, students. On this clip, we're going to be going over 6 examples on differentiation. So as you can see, the learning objective as part of the stage series. So basically, we're going to learn how to use the 6 basic differentiation rules to find the derivative of function. All right. So let's go ahead and consider these. First one, rule number one, is the derivative of a constant function. Basically, if c is a constant, then the derivative of that constant is 0. All right. So let's apply that to an example. Problem one, it says find y prime where y is equal to pi. So remember, the derivative of a function, you can write dy dx, is the same thing as y prime. Okay, so don't let this symbology throw you off, right? D of a function dx is the same thing as y prime, all right? So y prime in this case, we're basically looking for the derivative of this function. So y prime is, which is equal to dy dx, is going to be the derivative d dx of what is y? Y is pi, right? So d dx of the function pi, all right? All right, so in this case, if we compare this situation we have right here to this formula, in this case, the constant is pi. You know that pi is a number, right? It's a constant 3.14 goes on like that. So since pi is a constant, the derivative of constant is equal to 0. So the derivative of um, pi with respect to x is simply 0. So they could get final answer. Okay? All right, now let's move along to another example. Rule number two is known as the power rule. Um, it says that if n is not equal to 1, if n equals to 1 is a special rule for that. If n is not equal to 1, um, then we can use the power rule right here. We have the derivative of x to the n, the respect to x, is n times x to the n minus 1. All right, so just to give you a visual, if you have a function x to the n, all you do is you move it, whatever the exponent is, you move it to the front, n, and you just subtract 1 from the original exponent. All right, so move the power to the front and then subtract 1 from the power. Okay, so that's basically how you get the derivative of that, which is basically n times x to the n minus 1. All right, so that's what this formula is telling us to do. All right, let's apply this power rule to this problem right here. It says find the first derivative of the given function f of x equals x to the 12th power. Okay, you can see in this case that n is equal to 12 because that's what power x is being raised to. Okay, so using the rule, the derivative dx of the function f of x is going to be, you see this 12 right here, we can bring it to the front, 12 times, and it will subtract 1 from the power 12 minus 1. Okay, so we have n corresponds to the 12 right to the front, and then n minus 1 is 12 minus 1. All right, let's go ahead and simplify that one step, and it will be done. So we're going to have 12x to the 11th power. All right, so that is the derivative of f with respect to x is 12 to the x, I mean 12x to the 11th power. Okay, so there you have it. All right, let's try another rule. This is known as the constant multiple rule. All that this is telling you is that whenever you have a constant in front of a function, you can factor out that constant to the front of the derivative and focus on differentiating the function. Okay, so constants can be moved outside the derivative, and they can focus on the function as long as the constant can be factored out completely out of the function. Okay, so that's how we have the formula, the derivative of c times. Notice that the constant is being multiplied by the function. The constant is being multiplied by the function. That's why we can factor it out. Okay, the constant will be added or subtracted to the function. Then you cannot apply this rule. All right, so multiple basically means that the constant is being multiplied by the entire function. That is why we can factor it out. Okay. So let's take a look at this example. It says find y double prime, the second derivative of this function right here. So we have y is equal to 3x to the second. So let's write it here. Y is equal to 3x to the negative 2. So let's do dy dx, the first derivative first. Dy dx is equivalent to y prime. So what this is telling me is that if I want to differentiate, if I want to find ddx of this entire function, 3x to the negative 2, this constant multiple rule tells me that this constant can be factored out of the derivative, and then I can just focus on differentiating the function. So what on earth does that mean in the context of this example? It basically means that you see this 3 here, it is a multiple of this function, this rational function 1 over x squared x to the negative 2. So I can factor it to the front and write it as 3 times the derivative of the function x to the negative 2. Okay? So this will yield the first derivative. Let's go ahead and compute that. So we're going to have, let's see, we're going to have 3 times, if we apply the power rule here that we went over before, we can bring that power to the front of x, negative 2, x to the, and then subtract 1 from that power, minus 2 minus 1. Okay? Remember that formula, let me write it over here, ddx of x to the n. We talked about this, is n x to the n minus 1. Bring the power to the front and then subtract 1 from the power. That's exactly what I did here. This was the power, negative 2. I brought it to the front and then I subtracted 1 from it. Okay? So applying the power rule, I get this result. So let's go ahead and simplify it, and then we're going to differentiate again. So this is the first derivative. Y prime is equal to negative 6 x to the negative 3. Okay? All right, we're not done yet. We have to find the second derivative. So we have to differentiate again. So I'm going to find ddx of y prime. Okay? This is the same thing as the second derivative, y double prime. All right, so ddx of y prime. So basically, I'm going to be taking ddx of this whole business right here, negative 6 times x to the negative 3. All right, so how do I apply the constant multiple rule here again? Remember, the constant multiple rule tells you that if you multiply a constant by a function, as it is here, you can factor out the constant and then focus on differentiating the function. All right, so I'm going to factor out the constant, negative 6 times d dx, the derivative of the function x to the negative 3. Okay? Now let's apply the power rule to this, to the differentiation of this. Let me refresh your memory. Remember the power rule, d dx of x to the n. Simply bring the power to the front of the x and then subtract 1 from the power that was there before. That will give you the derivative of this term, which is the power. All right, so let's apply that here. Just bring down the negative 6 that was factored out, times, I'm going to bring this power, negative 3 to the front. A bit bigger. Negative 3 to the front. And then I'm going to have x to the subtract 1 from the power, minus 3 minus 1. Okay? So if I simplify this completely, that would give me y double prime. Okay? So it's going to equal negative 6 times negative 3 is negative, I'm sorry, it's positive 18 because minus times minus is plus. Positive 18 x to the negative 4. Okay? Or it can also be written as 18 over x to the 4th. Whichever way you want to express your answer, it's perfectly fine. Okay? So there goes the application of the constant multiple rule. We also have to use the power rule here 2 times also. All right? Okay. Advance to question number 4. Rule 4. Before the sum of difference rule, it says that you're going to be functions of x, then the derivative of the sum of the difference is equal to the derivative of the individual sum of differences of each term. So what this is telling you basically is if you have a sum of difference of terms, you can distribute the derivative to each term that's been distributed. Okay, so if you're summing two functions, two terms of a polynomial function, then you can simply distribute the derivative to each term. Basically, you're doing term by term differentiation here. Okay, term by term differentiation. You can differentiate the first term, add or subtract the derivative of the second term, or what you get when you differentiate the second term. That's how you arrive at this. Okay, so it's perfectly fine to to distribute the derivative over the sum or the difference. But note though, you have to be really careful about this. Note that the derivative of the product is not equal to the individual derivatives ddx of u times ddx of v. This is wrong. Okay, you can distribute derivative over sum or differences, but you cannot distribute derivative over product, and you cannot distribute derivative over quotient. So you have u divided by v. This is not equal to ddx of u divided by ddx of v. All right, derivative can only be distributed over addition and subtraction. Okay, these two, they have special rules that apply to them. We'll look at them later. All right. So let's take a look at this example, problem 4. It says find the df for x is equal to x squared minus 3x plus 5. All right, so let's go ahead and compute the derivative here. So f dx basically is the derivative of this entire quadratic expression, 2x squared minus 3x plus 5. So what is the formula about? What did it tell me? It told me that you can distribute the derivative to each term. So what is it going to look like in the context of this example? Basically, you're going to have d dx of the first term, which is 2x squared, minus the derivative d dx of the next term, which is 3x, plus d dx of the last term, which is 5. Okay? All right. So this is what the rule is telling you to do. Basically, you can distribute the derivative across everything. Okay, so for the first one, we're going to use the constant multiple rule and the power rule. Let's use the constant multiple rule first. This 2 can be factored out. We have 2 times the derivative of x squared. And in this one, I can also factor out a 3 because you have a constant multiple rule here. 3 times the derivative of x. Okay. And then this, you're going to use the constant rule. Remember the constant rule, the derivative of a constant is what? 0. Okay, so this is going to be plus 0. Now let's apply the power rule here. If I apply the power rule in this case, I'm going to have 2 times the derivative of x squared is 2. You bring the power to the front times x to the what? 2 minus 1. Okay? Minus the same thing here, bring down the 3. There's 3 times. This is x to the 1. Bring the 1 to the front, and then times x to the 1 minus 1. 1 minus 1. This 0 goes away, all right? It doesn't play any role, so it's inductive. All right, let's finish this up. So the f dx is basically going to be 2 times 2, which is 4. 4x, 2 minus 1 is 1. Minus 3 times 1 is 3. X to the minus 1 is x to the 0th power, right? So that's simply going to become 4x minus x to the 0 is 1 minus 3. Okay? So the derivative of the function, so the derivative of function f of x is equal to 4x minus 3. Okay, let me write it properly. Sorry about this. So you're going to have ddx of function is 4x minus 3, and there goes your final answer. All right, now let's move on to the next rule. What's my answer? That goes your derivative. The next rule is the product rule. Remember I told you that you cannot distribute the derivative over the product, right? This is the rule for the product. So it says let u be the function of x, then uv prime is equal to du prime plus uv prime. So basically you can you have to do this. For this formula, we need to do differentiation the product of 2 functions, all right? So in this problem 5, it says find the derivative at x equals 1 of this function. So all this is telling you to do is first of all compute the derivative and then plug in 1 for your final result. Okay? So if you take a look at this example, just to make your life easier, you can think of this as u. In the alphabet, U comes first, right? And then V. Okay, so that's U, and then that's V. So let me just write down the rule. I'm going to write down the formula here so that it guides us. Okay, so F prime, the same as dfx, F prime is equal to let me switch the order. It doesn't really matter the order, but I like to write it like this using V first because it's similar. It helps you remember this one and the other one we're going to see next. So V, U prime plus U, V prime. All right. So if I apply that to this formula, this function we have, so V is 2x squared plus 3x, that's V. And then U prime is going to be 3x squared minus 1 prime. Okay, plus U, which is 3x squared minus 1, and V prime, which is 2x squared plus 3x prime. All right. Now, we're just going to bring down this term, 2x squared plus 3x, and then we're going to differentiate this term right here. So we're going to use the term by term differentiation. Remember I told you that earlier that you can distribute the derivative over some of the differences. So in this case, on the left side, it's going to become this expression times 3x squared. Oh, you're right. Let me write that again. Times 3x squared. Keep writing it here. 3x squared prime minus 1 prime. Okay, distribute it to each term. Okay, plus, and then bring down this 3x squared minus 1 times. Notice how I'm encapsulating this whole derivative in a bracket. Okay, because we're going to resolve it first and then distribute 3x squared to whatever we get. Okay, so this side is going to be, we're going to use the sum and difference rule again. So we can distribute the derivative to the sum of these two, right? So it's going to be 2x squared prime, which is the derivative of the first term, plus the derivative of the second term, which is 3x prime. Okay? All right, let's go ahead and finish this up. And then we're going to plug in 1 for our x's, okay? All right, so let's go ahead and do this. So we're going to just bring this down, parenthesis, quantity 2x squared plus 3x. And then the derivative of this, we're going to use the power, if we use the constant multiple rule, it's just going to be 3 times x squared prime. So I've factored out the 3 out of the derivative. Using the constant rule for 1, the derivative of a constant, which is 1, is just 0. Okay? Plus, and on the right side, we just bring out 3x squared minus 1. Apply the constant multiple rule here, factor out 2, and then we're left by x squared prime. Okay, so you can always factor out a constant multiple of the function. Same story here, I can factor out 3 and then just focus on differentiating x to 1 prime. All right? Okay, that's just 1, and that's prime. Okay, advancing along, we're going to just bring down 2x squared plus 3x. And then our derivative of x squared is 2x. Using the power rule, you bring down 2 to the front, and then you subtract 1 from the power, 2 minus 1. This whole thing is 0, right? So I can just forget about that one. Plus, bring this down, 3x squared minus 1. And then this one, we're going to apply the power rule also. 2 times, bring the 2 to the front, x to the subtract 1 from the power, 2 minus 1. Plus, power rule here again, 3 times, bring the 1 to the front, and then x to the 1 minus 1. All right. Okay, we're getting closer to the answer. So this is, it asks for, I say f prime it asks for? Yeah. Okay, so f prime of x is going to be, we have 2x squared plus 3x times, and then if you evaluate this, you have 6x to the first power, plus, on this side we have 3x squared minus 1 times, if you evaluate that, you have 4x to the 1, and then this is just, this x is 0 is just 1, right? So just plus 3. Okay. And then on the simplifying further, we can distribute 6x to both sides here. This and this. So that's going to give me 12x to the third plus 18x squared. And then on this side, we have to distribute twice. So we do the 4x. Okay, so one thing I can do here is I might as well start organizing while I'm distributing, right? So 4x times 3x squared is 12x to the third. 12x to the third. And then 4x times 1. Wait, let's do it this way. So 3x squared times 4x is 12x to the third. 3x squared times 3 is going to be 9x squared. So 9x squared. And then negative 1 times 4x is negative 4x. Then negative 1 times 3 is negative 3. All right, so we just add it downwards, and that should be our derivative for any arbitrary x, and then we're going to fix it to a specific point, namely x equals 1. All right, so let's add it downwards. So if we add it downwards, we're going to have 24x to the third plus 27x squared minus 4x minus 3. And this is f prime of x. Now what is f prime of 1? That just means that you substitute 1 for all the x's, okay? So you have 24 times 1 to the third plus 27 times 1 squared minus 4 times 1 minus 3. All right, so that simply yields 24 plus 27 minus 4 minus 3. This is negative 7, right? So we just have 24 plus 20 because 27 minus 7 is 20, and then that's your final answer is 44. Okay, so f prime of 1 equals 44. All right, last but not the least, let's try one more example. The last rule is the quotient rule. Remember I told you that derivative does not distribute across division or multiplication. This is a special rule for division. Okay, so du prime minus uv prime divided by v squared. Okay. All right. So let's go ahead and see if we can apply this formula to this. It says find y prime of 2 where y is equal to x plus 5 over 2x minus 1. If you want to apply the quotient rule, it's good to identify what u and v are first, and then write down the formula and then substitute the corresponding functions into the spots that were created in the formula you wrote. All right, so let's look at this. If you look at this right here, obviously the numerator is u. In this case, u is basically x plus 5. And then the denominator v is that's what v is, plus minus 1. Okay. So let's rewrite the function down here, and I'm going to use it to evaluate y prime, and then when we're done, we will substitute 2 into our x values. All right, so y prime is going to be v u prime low d high minus uv prime, which is basically high and below, over v squared, which is low squared. There's a mnemonic device most people use, I don't know. They say, and this is the high, and this is low. High means you're in top, low means you're in the bottom. You just have low times the derivative of high, low d high, minus high d low. High times the derivative of the low, high d low. So it's not high d low. So low d high minus high d low over low square. That helps you. It doesn't help me, but it helps some people though. So that's what I was saying here. So just remember this formula and you'll be good. Okay. So let's go ahead and apply this formula to this example. All right. All right. So that's gonna give us y prime equals v is 2x minus 1, 2x minus 1 times u prime, which is x plus 5 prime. That is v u prime minus u v prime. U is x plus 5 times the derivative of the divide the whole business by b, which is the denominator, which is 2x minus 1 quantity squared. Okay, so 2x minus 1 quantity squared. All right, so now let's go ahead and simplify this. So in the numerator, we're going to have 2x minus 1 times, to differentiate this, we're going to use the sum and difference rule. So this derivative can be distributed to each term in here. So it's going to be times x to the 1 prime plus 5 prime, okay, minus, and then the same story here, bring down x plus 5, and then we'll have, okay, let me use a squiggly bracket here because I'm going to be grouping stuff inside. So times, parentheses 2x prime minus 1 prime, close that, and then divide the whole thing by 2x minus 1, 2x minus 1 squared. Okay. All right. Now let's go ahead and finish this up. So we're going to have on the denominator, on the numerator, 2x minus 1 times, this one is going to be, we're going to bring the 1 to the front. So it's going to be 1x to the 1 minus 1. This is the power rule. Okay, remember the power rule, you bring the power to the front and then subtract 1. And then for this one, this is a constant, so just put 0. That constant rule, minus x plus 5. And then on this side, we can factor out the 2 and apply the constant rule. So x to the 1, so it's going to be 2 times 1 times x to the 1 minus 1 minus 0. Okay? The more of these you do, you can do multiple steps at the same time to save time. Okay? So if you do a lot of practice, then you can start taking shortcuts so it doesn't take you forever to solve on some problems. Okay? And then it's going to be divided by 2x minus 1 squared. All right? Okay, so let's finish the top. The top will have 2x minus 1. And then here, this whole thing is, this is x to the 0, which is just 1 times 1 minus x plus 5. And then this whole business right here is just 2 times 1, which is 2. And then that's divided by 2x minus 1 squared. I'm going to be substituting something for x, so I don't need to waste my time expanding this, okay? So let's simplify the numerator and then plug in. So this is f prime of x so far. So we're going to have 2x minus 1. If you distribute 1 to these two, nothing changes. Minus 2x. Don't forget to distribute this minus to this plus right here to make it minus 10. I distributed this 2 to the x into the 5. Okay? All right, over, oh boy, let me do that again. Over 2x minus 1 quantity squared. All right, 2x minus 1 quantity squared. All right, numerator simplifies further. These two x's cancel out. So we're going to have negative 11 divided by 2x minus 1 quantity squared. Okay. All right, so that's basically the derivative. So we're going to have f prime of x equals negative 11 divided by 2x minus 1 quantity squared. All right, but the question asks for the derivative at 2, y prime of 2, okay? So y prime of 2 basically means we're just going to plug in, 2 into my x's, okay? So remember, y is equal to f of x, they mean the same thing. So we're going to have negative 11 over 2 times 2 minus 1 quantity squared, okay? And then we're going to use order of operations here to simplify this. Negative 11 over 2 times 2 is 4 minus 1 squared. You're going to have negative 11 over 3 squared. It's going to be negative 11 over 9. And there goes your final answer. All right? That's y prime of 2. Okay. So thanks so much for taking the time to watch this video. Please subscribe to my videos here for future updates and cool clips such as this, and also you can share with your friends on Facebook or Twitter. More math videos can be found on mathdistrict.com. Thanks again and have a wonderful